When considering the many practices that correlate and connect to the mathematics and its studies, it's necessary to acknowledge how important and essential fractions are to everything. Almost every subject in math has to do with fractions.
I just had to show off that swag video.
But anyway, to fully understand what a fraction is and its functions, it's very crucial to see an example of when it may be used. So let's go do that. So in many elementary schools or any place to learn fractions, it's most often taught through a pizza or a pie. So say that this is the pie, right? Great circle, I know. Say that this is the pie or the pizza, doesn't matter. Say that there's 4 pieces, okay? 4 pieces. Say that one of these pieces are eaten. Okay? You have 3 pieces that are not eaten, right? So fractions are always written in this formula. So how many possible outcomes there are, or how many numbers that could be used up? So there's only 1 piece eaten, but there's 4 possible pieces to be eaten. So that overall number always goes on the bottom. So in this case it would be 4. And if the question is how many were eaten or how many are gone, in this case 1 was taken. So 1 out of 4. So you take that 1 and you put it up here. So this is how a fraction looks. After you take your data set or your chart, in this case it would be a graph, or like a chart, graphic, basically. You take how many were taken or eaten, in this case it's eaten, put it on the top, which is your numerator, and on the bottom is your denominator. Your denominator is always the overall. And it can be for any number. You could do 8 pieces. It really does not matter, as long as it's easy to tell how many you can do it. So this would be 8. Now Google defines a fraction in 2 significant definitions. The first definition is a numeric quantity that is not a whole number. So when looking at the pie chart example that I showed, it was 1/4 of the whole pie. That is not a whole pie. A whole pie, or a 1 whole pie, 1 is all the pieces, but 1/4 was eaten, so it is not a whole number. And the second definition is a proportion of something to make it whole. And both of these definitions can correlate to each other because they both mean that a fraction is not entirety. They connect together to make a whole. Now the cool thing about fractions is that there's no limit to what the numerator and the denominators can be. The 4-piece limit that I've kind of set is just the start of where you can go. There are vast number sets and fraction orders that you can set, and they are infinite. You could have a numerator of 975 and a denominator of 24. You can have a numerator of 35 and then a denominator of 9,783,000. It doesn't matter what the numbers are, as long as they make sense and they're not a whole number, they're a fraction. And especially if you're considering the possibility of infinity, there could be infinite slices, there could be an infinite denominator. Now, despite these huge numbers that aren't very realistic for fractions, there are a few examples that could happen. So for example, this bench press, say that there was a master a master gymnast, and he was able to bench press 1,000 times. Okay, this man is amazing, and he's able to bench press 160 pounds 1,000 times. So he sets this goal for himself, and he goes for it. Say that he stops at exactly 999 reps, okay? That fraction would be 999 out of 1,000. That's how many he bench pressed. Now, it's not very realistic that somebody could bench press 1,000 times, though there are other instances, such as food stock markets or populations among areas. These do get in high numbers, and looking at what they once were to what they are now, there are fractions for them. Now, since I already discussed what a fraction is and how it can relate to real life in the big numbers, it's important to talk about how and what studies or practices of math they can link to, such as percentages or decimals or division. Now, the cool thing about fractions is that if it doesn't directly point to a certain subject of math, it can convert to a decimal or a percentage through multiplication and division. So take this, the 1/4 of a pie I showed. So it obviously equals that, the 1/4 of how much was eaten. But you can just look at 1/4 as a division problem, because that's all it really is. So when you pull out a calculator and divide 1 divided by 4, you get 1 divided by 4. Once you do that, that will equal the decimal of how much this will be. So that is 0.25. So 0.25 out of 1 is, the 1 is the whole, and the 0.25 is how much was eaten. And yes, that is 1/4. Now, to get the fraction to a percentage, I couldn't find my pencil there, but to get this fraction or this decimal to a percentage, you just have to do a fraction. So, but the entirety of the decimal is 100. It's always going to be 100. So something out of 100 equals what it's going to be in percentage form, because a complete percentage is something out of 100. If the numerator is over 100, that means it's the total plus some. But in this case, it's going to be 0.25 out of 100. So I'm not going to show how to simplify, because I'm just not getting to that. This is the overall of fractions. But this can be simplified to this. Now, reaching to bigger numbers is a bit tricky, but it is possible. So say that this is the pie, and it has 8 pieces instead of 4. Okay, say that 1 is shaded out. So that equals 1/8, because there are 8 pieces and only 1 is taken. So 1/8, and when you divide this, it's going to equal, so you just have to do that. That's literally what it is. And when you go to a calculator and divide this, it's going to equal 0.125. But as a fraction going to a percentage, this is going to look a bit weird, because what I showed before for this one, obviously you can just take the 0.25 and bring it over. For this, it's a bit more tricky, because you obviously have to go 100, but there's not a 1 here. That is not existent. This is a 3. It goes to the thousandths place. So this is a bit more tricky, because obviously if you just did take the number, it would look like that. Now, to see how this became 25%, because it's 25 over 100. The number that's over 100 is what percent it is. So that's 25%. To see how we get from that, something like that, to find the answer for this, because that obviously doesn't make sense, we need to move the decimal place 2 places right, because that is what finds the answer. I'm not too sure why, but this is the rule. So doing the same for over here, this would obviously be 0.125. You'd move it 2 places right. So if you put it there, it's gonna be 12.5 over 100, meaning the answer is 12.5%. Fortnite Battle Royale.
So by the end.
By the end, fractions are numbers that aren't fully whole numbers that are represented through a numerator and a denominator. They can be big and small, or very obscure, but they always make sense and are usually used in a real life circumstance. Now, this video is purposely sucked. It's not meant to necessarily educate just for the jokes, but it is an overall idea nonetheless. You can go to any other fraction tutorial on YouTube and find the same thing, if not better. And there are several other issues relating to fractions that I did not touch on, such as rationalizing, simplifying. Fractions can be whole numbers, but they can just be written differently. A fraction can represent a whole number. Regardless of how well people perceive their use, fractions are most definitely useful among other math tactics and uses. Okay, goodbye.